So the today topic is the torque slip characteristics of torque slip characteristics of induction machine. Torque slip characteristics of induction machines are rectangular hyperbola. So when torque is proportional to slip, the operation is stable, that is linear mode, and torque is inversely proportional, then operation is unstable. Electromechanical torque produced by the interaction of two magnetic fields and load torque developed by the load, and electromagnetic torque is act in the direction of rotor rotation in the motor, and electromagnetic torque act in the opposite direction in the rotor direction in generator. Maximum torque less than load torque, then unstable mode. Sorry, electromagnetic torque is equal to load torque, then it is a stable operation. So maximum torque equal to full load torque. Full load torque is a torque produced by full load torque is produced by an induction motor which pulls the rotor from stable to unstable region. Full load torque is the torque produced by an induction motor which pulls the rotor from stable to unstable region. Full load torque which pulls the synchronous motor out of synchronism. Which pulls the synchronous motor out of synchronism. So the synchronism means stator's flux speed and rotor speeds are same. Stator flux speed and rotor speeds are same. It's called synchronism. The stator and rotor is running together. But when the loads are increases, then the load angle between stator magnetic flux and rotor flux axis, between that stator flux axis and rotor flux axis, there is a angle is called alpha will be increases. If alpha increases behind 90 degrees, then machine will be out of synchronism. A 6-pole 50 Hz induction motor running at 950 rpm. Torque developed by is 80 Newton meter. The rotor impedance is 0.2 plus j plus j 0.6 ohm. There is a 2 ohm resistance is added to the rotor circuit. Then find the torque developed by the machine. Then find the torque developed by the machine. So 6 pole 50 Hz induction motor running at 950 RPM means NS is 1000. NS is 1000, NR is 950, and torque developed by is rotor is 18 Newton meter. The rotor impedance is 0.2 plus J 0.6 ohms. Then 2 ohm resistance is added. When the resistance is added, then torque will be increases from 80. So actually we know that torque is directly proportional to rotor resistance. So initial torques are T1 proportional to R2 and T2 proportional to R2 plus R external. Already there is a 0.2 resistor is there in circuit. So now there is a 2 ohm resistor is added. So the 2 ohm resistor is the external resistor. T2 equal to 2 plus 0 0.2 by 0.2 into 18 meters. Then T2 is the 880 meters. Torque is 880 Newton meters. Maximum torque occurs when R2 is equal to S60 and R2 equal to S60. And maximum torque is directly proportional to E2 square and inversely proportional to X2, and it is independent on rotor resistance. But slip at maximum torque depends on rotor resistance and it is proportional. The maximum slip proportional to R2 by X2. R2 by X2. Maximum torque proportional to E2 square. Tmax proportional to 1 by R2. So this is the torque slip characteristics. slips are 0, that means n is equal to nr. Slips are 0, n is equal to nr. Slip equal to 1, in that nr equal to 0. When slip equal to 1, nr equal to 0. So slips are varies from 0 to 1. Slips are varies from, say in the here, slip varies from 0 to 1, and speeds varies from nr equal to 0 to nr equal to ns. It is just reverse of slip. Speeds and rotor speed and slips are inverse relation. Rotor speeds are increasing, slips are decreasing. Rotor speeds are increasing, slips are increasing. Rotor speed and slips are inverse relation. At starting, slip equal to 1. So in this condition, the torque and the slip characteristics are inverse relation. It is because of in the torque equation, right, in notes, the torque equation T proportional to SE2 square R2 by R2 square plus SX2 square. In that there is a slip at numerator and denominator, but at starting rotor frequency is more. So when there is a rotor frequency is more, the SX2 term is more dominated in the denominator as compared to the numerator S. So it is more dominating SX2 square at denominator. So rotor reactance SX2 square is greater than the rotor resistance. Rotor reactance is greater than rotor resistance. So T proportional to 1 by S is considered. So in that 1 by S, it is a parabola, hyperbola, rectangular hyperbola, and this is at starting condition. When machine reaches to the one maximum speed and maximum torque condition, and if the speeds are remains increasing, then slips are decreases. After reaching of maximum torque in the machine, the loads are increases. Sorry, loads are decreases. Speeds are increasing. When speeds are increasing, slips are decreases. Slips are decreases. So Under running condition, rotor frequency is very less. So the Sx2 square term is in the denominator is negligible. When denominator Sx2 square term is negligible in the torque equation, that is rotor resistance is considered the rotor resistance is greater than rotor reactance. In this case, the torque is proportional to slip. In this case, torque is proportional to slip. So see in the figure T maximum torque, and the machine is running with the Tm equal to Tm. Tm is the electromechanical torque. In motor, it act in the direction of rotor rotation. Tem equal to Tl. So when slips are greater than 1, machine is braking mode, and slips are between 0 to 1, there is a motoring mode, and when slips are negative, then generating mode. Slips are negative, then it is a generating mode. Braking, motoring, and generating mode. Slips are greater than 1, braking mode. Slip is between 0 to 1, motoring mode, and slips are negative, generating mode. When induction machine operating with a low slips or TEM equal to TL or at stable region, torque versus slip is linear. When an induction machine is operating with high slips, TL is greater than T maximum or unstable region or unstable region. Torque versus slip is a rectangular hyperbola. An induction machine is operating with a higher slip. The higher slip means at starting condition we get a higher slips. So in that condition, load torque is greater than maximum torque. Yeah. So this is called the unstable region. So in this condition, torque versus slip characteristics are rectangular hyperbola. So at starting, the torque slip characteristics are rectangular hyperbola, but with running, the torque slip characteristics are linear. T maximum, that is the maximum torque, is independent on rotor resistance. If rotor resistance is added, starting torque only increases, but there is no change in the maximum torque. And if rotor resistance is added, maximum slip value will be increases proportionally. The maximum slip Sm proportional to R2 by X2. Maximum slip increases, but not maximum torque. So see the graphical representation, rotor resistance are increasing. So here just correct it. Rotor resistance and slips are proportional. So here there is a wrong. Just correct in proportional to the rotor resistance. Slips are increasing from R1 to R4. Resistance are increasing from R1 to R4. Then slips also increases from SM1 to SM4. A three-phase, six-pole induction motor running at 1450 rpm with a rotor impedance Z2 equal to zero point 0.1 plus J 0.60 to get maximum target starting. Then find the rotor resistance is to be added. See that to get a rotor maximum torque in the machine, to get a maximum torque in the machine, a rotor resistance equal to Sx2, but S is 1 because at starting S equal to 1, R2 equal to Sx2, but S equal to 1, then R2 plus X plus X2. Rotor resistance is added, then must be equal to rotor reactance. Already there is a zero point 0.1 ohms of resistance is there. To reach 0.6, the zero point 0.5 ohm resistance has to add it. Whenever rotor resistance and reactance is equal, then only an induction machine develop a maximum torque at starting. A 50 Hz 8-pole induction machine running with a 4% slip, 50 Hz 8-pole induction machine. When 8 poles are there, then Ns is equal to 750 rpm. Ns equal to 120 F4 by T is 8. The rotor resistance added Standstill reactants are 0.01 and zero point 0.1 ohm. So the rotor resistance and standstill reactance are zero point 0.1 ohm respectively. The speed at which the maximum torque occurs. So we should calculate in NS value. So find the maximum slip first. That is R2 by X2. R2 by X2 equal to 0.01. R2 value and X2 value is of 0.1. So from that, the slip is zero point 0.1 ns minus nr by ns. Here ns value is 750 and nr equal to ns into 1 minus s. 670. Five 25, D 750, C 612, and D is the 675 option. So nr equal to ns into 1 minus s. So right. An 8 pole 50H 3-phase induction machine has an equivalent resistance of 0.01, 0.07 ohms per phase. If it is stalling speed is 630 rpm, then find the rotor resistance. So here given a rotor resistance per phase value, speed is given nr value 630, slip 0.16, x2 value is r2 by s. So to find the rotor reactance, x2 equal to r2 by s. R2 value is 0.07, slip value is 0.16. So the rotor reactance is 0.44. Next topic is the double cage rotor. Double cage rotor. Double cage rotor is continuation topic of it is a construction of induction machine. So in a squirrel cage induction machine there is a problem that rotor resistance value is very less. So because of rotor resistance value is less, there is a three disadvantages. One is the starting current is very less. Sorry, starting current is high, and starting torque is more. Starting torque is less, and power factors are low. Starting current is high, torque is low, and power factor is low. So it is because of rotor resistance is very less. So to overcome this problem, we go for skewed rotor method and double cage rotor method. In skewed rotor method, the rotor bars are inclined to the shaft. So the bar rotor bars are effective lengths are increases. Then squirrel cage rotor. So effective lengths are increasing, then resistance are increasing. When resistance are increasing, starting current, high starting current comes to low level, the medium level, and starting torques are increases, and start power factors are increases. But in a skewed rotor method, the disadvantages overcome is very less because rotor resistance increasing in the skewed rotor method is very less. So now coming to another structure is a double cage rotor. A double cage rotor is a modified construction of squirrel cage rotor. So in a double cage rotor there is a two cages are there. One is a outer cage and one more is a inner cage. Outer cage has the low area and inner cage has a high area. So as we know R2 is proportional to rho L by A. So the the conductor resistance is inversely proportional to area. In area wise, outer cage and inner cage. So the inner cage is more area. So inner cage has the less resistance and outer cage has a less area. So inner cage has more resistance and less reactance. In the outer cage, resistance is more and reactance is less. In the outer cage, because of area is very less. And inner cage, because of area of inner cage is more, so resistance is less and reactance is more. So outer cage impedance equal to R2 plus JSX2 and inner cage impedance equal to R in plus JSX in. At starting, rotor frequency is equal to stator frequency. It is because of slip equal to 1. Slip is 1 because of NR equal to 0. So substitute NR equal to 0 in the slip formula, we get a slip equal to 1. Rotor frequency is high, hence reactance is high. Starting rotor reactance is starting rotor frequency is more because of rotor reactance is x2 is proportional to fr. When frequencies are more, rotor reactance also more. So when the rotor reactance are more, so the inner cage offers the highest impedance. Inner cage offers the high impedance at starting. At starting, rotor reactance is more greater than the resistance. Z out equal to R2 plus J is 62. So between inner and outer cage, the impedance at starting in inner cage is more. So the current flows from the outer cage. In inner cage, impedance is more. So current flows from outer cage. In the outer cage, current flows at starting. So because of rotor resistance, because of resistance is more for a outer cage, starting current is decreased, starting torque is increased, and power factor also improved. So when machine is running, rotor reactance is decreases to very less. It is less than rotor resistance. So in this condition, when it is running, SX2 term is very less as compared to R2. So in this condition, reactants are very less. So resistance is dominated. So resistance is dominated in the outer cage. So outer cage provides a higher impedance. When outer cage is provided higher impedance at running condition, then current flows in the inner cage. In inner cage, there is a resistance is very less. So machine is already running. There is no problem with the torque and currents and power factor. If resistance values are decreasing, when resistance values are decreasing under running condition, the copper loss also minimum. Copper loss are minimum. So with the double cage rotor, the torque achieved is more as compared to skewed rotor and squirrel cage rotor. Double cage rotor gives the more torque than skewed rotor and squirrel cage rotor. So if you want some extra torque, go for the slip ring induction machine.